Hey Precalculus, today we're going to be doing section 242, determining zeros of a polynomial. So in our last video and live lesson, we learned how to use the rational zero theorem to solve for zeros, we'll solve for rational zeros, but how can we determine if they are actual zeros? So a couple things. First of all, be careful. Some numbers or zeros, they can be double or triple zeros. And then your goal is to get down to a quadratic. And then factor. Factor your quadratic by grouping, just like you know and accept, or maybe know and love. Okay, so we're going to start with an example that we actually did in our video lesson. So list possible zeros. That's how all of these problems are going to start, because we need to know what are the possible zeros first before we can determine which ones are actual zeros. So list all possible zeros, then determine which, if any, are zeros. And the function I'm going to give you is g of x equals x to the fourth plus 4x squared, just kidding, 4x cubed, minus 12x minus 9. Alright, so the first thing we need to do is determine the possible zeros. So I'm going to write steps off on the side, which I recommend you do too. So first, determine possible zeros. Alright, so factors of your constant, which is 9, divided by factors of 1. So this one's going to be easy. Well, it's going to be easier because it's factors of 1, so that's just 1. So factors of 9 are 1, possible 3, or 9. And remember, all of these are plus or minus. And then factors of 1 are 1. So then we divide. So we have plus or minus 1, right? 1 divided by 1, 3 divided by 1, 9 divided by 1. Now, that means our possible zeros are 1, -1, 3, -3, 9, -9. And be careful, because we could have double or triple zeros, meaning there could be like 3, it could be like x plus 1 squared or x plus 1 cubed. All right, so that's step 1. And then step 2 is where it kind of gets tedious. So step 2 is we're going to use synthetic division to determine a zero. So that's the remainder equaling 0, right? So if we use synthetic division with one of these and we get a remainder of 0, then we know that is one of the zeros. So you can pick one to start with. Let's start with 1. So right now we are testing, is positive 1 a 0? So we list out the coefficients and then be careful because it's 4, 3, 2, 1. So our coefficients are 1, 4, 0, negative 12, negative 9. We're going to bring down the 1. We need to have our bar here, and then this is where the remainder goes. So bring down that 1, and then we multiply. So 1 times 1 is 1, and then we add. So 4 plus 1 is 5. 5 times 1 is 5. 0 plus 5 is 5. 5 times 1 is 5. Negative 12 plus 5 is negative 7. Negative 7 times 1 is negative 7. And then we add and we get a remainder of 16. So we have concluded 1 is not a 0. It's a possible 0, but it is not a 0. So this is where it's tedious. We now choose another one. And as you can imagine, it's going to get harder when we have more possible zeros. That's okay. You'll get better at it. So let's choose negative 1. So same process, we're just doing it with a different number. So make sure you set this up correctly so you don't lose points for that. All right, bring down the 1. 1 times negative 1. 4 plus negative 1. 3 times negative 1. 0 plus negative 3. Negative 3 times negative 1. Negative 12 plus 3. Negative 9 times negative 1. Negative 9 plus 9. So that's awesome. We have one of our zeros. So the next step, once you have a 0, rewrite and keep going if needed. Well, keep going until you have a quadratic. So this is where we're at. We know that x plus 1, right? Because this is c, so that means it's going to be x plus 1 is a factor. And then this becomes constant x squared, x cubed. So this is our new function, x cubed plus 3x squared minus 3x minus 9. So now we do the same idea, because this is not a quadratic, so we're going to reapply this whole thing, but to this function. So now we can figure out, okay, we don't have to do like the possible zeros because we know it's still one of these. So if we want, we could do negative 1 again. You kind of just pick and choose. You could do negative 1, negative 3, positive 3, 9, negative 9. So I don't know, let's do negative 1. How are we doing on time? We're doing okay. So I'm going to test negative 1 again because remember it could be a repeated 0, but now I'm using these coefficients. So it's going to be 1, 3, negative 3, negative 9. So we bring down our 1. 1 times negative 1, add. 2 times negative 1, negative 3, plus negative 2, negative 1 times negative 5. And as you can see, it's just not going to work, so you can just stop. Alright, so now I need to test another one. Why don't we do -3? And you need to show every single test that you're doing. So 1 times -3, add. 0 times -3, add. -3 times -3, 9, add. We have a remainder of 0. Wonderful. So this is where we're at. We know we have to bring down the current factor, so we still have that x plus 1, excuse me. We just determined that x plus 3, and if you don't remember right, that's because this is when x equals -3, so our factor if we add it to the other side. So we know x plus 3 is another factor, and then we are left with x squared plus 0x, we don't need to write it, minus 3. So this is rewriting it in factored form, which you could be told or asked to do. So basically we can say this is g of x in factored form. And then the zeros are -1, -3. And then if we solve here, right, you'd add 3. And then you would take the square root. So it's plus or minus square root of 3. So as you can see, these problems are time consuming and you'll get better. It's just practice. So you have to show your work for determining the zeros. You need to show every time you try one. I won't make you rewrite it like this, but I think it's really helpful because I've seen students like forget to bring this zero down, the factor I should say, or they don't use this again. They start with the original, and the whole point is to like keep simplifying it. And then for this problem, I asked for the zeros, so you should make sure you list the zeros, and then be careful because I might just say factor, and so that means you would have to factor. And then, so, I don't know, step 4, rewrite and solve. Okay. And then if you have possible zeros that are fractions, my advice is just don't worry about the fractions. Solve for factors that are integers, and then you'll get to the point where you can get something like this, and that's how you can solve for things that aren't integers or rational, right? Because that's irrational, so that's not going to show up at all by doing synthetic division. So this is just going to take a lot of practice. If you're confused, it's okay. We're going to practice this in class, but I hope you guys watch the video.